Recording in progress.
Oh, okay.
Yeah, with nobody in it besides me.
That's how I record it, because when I record something, it's Zoom has the best expression out of everything, so it takes at least enough time for me to upload. Like if I can record using my camera software, or I can record using document camera software, but the files are huge. Zoom, I don't know what they do, but it makes it very small and works about half the time. All right. All right, that's all right, so on here, for our assignment from yesterday, again, you want to check your answers, but you also want to be careful because there are lots of different ways that you could write your answer and it would be correct. So for any of the ones where you have to write a proportion, all right, like on number 1, here you have 3 different ratios that you had to write. However, those 3 ratios can be written several different ways because it doesn't matter which one of the fractions comes first. It also doesn't matter the order in which the letters appear on the top or the bottom. Meaning on the first one, we had AB over DE. But if you switch the letters on top, so it was VA, that'd be fine. Switch the letters on bottom, so it was ED, that'd be fine. As long as you have those same 2 letters on top and the same 2 letters on bottom in that same fraction, you're good. All right. And then same thing for the other 2 fractions. So BC had to be on top, EF had to be under the B and C. CA had to be on top, FD had to be below the C and A. All right. And then it'd be a correct proportion. Now, the original statement there for similarity, this triangle is similar to that one. Well, that can also be written in several different ways, as long as you have the letters in corresponding order. So here we had ABC is similar to triangle DEF. Well, A and D are in the same corresponding positions. B and E are in the same corresponding positions, and C and F are in the same corresponding positions. So we had to make sure that the correct letters corresponded to one another. If I had switched the first statement around, then I could have switched the other statement around. Also, I could have flipped the statement completely and had DEF first and then ABC second. Now, if you did switch them around like that, that would also affect your proportions at the bottom. Because when you write your scale factor and your proportion, however you write that similarity statement, your ratio and your proportions should match that. So here, we're saying triangle ABC to triangle DEF. So since we wrote in that order, our scale factor, for example, was 32, with the bigger triangle to the little triangle. If I had ran it with DEF first, then technically I should have also flipped that scale factor. All right. So again, there are multiple ways that you can write these answers and still be correct. So you have to be careful though. If they instruct you to write something in a certain order, then you need to follow that order. If they don't give you an order, then there's a lot of different ways to write it. So these, again, there's lots of different ways there. They did include something extra on number 1 as well. They also specify that we didn't have that third angle up at the top, right? And in order to say that triangles are similar, you would need to know all the sides are proportional, all the angles are congruent. Well, we only had two of the angles given to us. We didn't have the third angle, but we had a theorem earlier in the year that was called third angle theorem. If you know 2 angles in one triangle are congruent to 2 angles in another triangle, then what had to be true about the other angle? They had to also be congruent. Same thing here. So here we have these 2 angles are the same as those 2 angles. Therefore, the top angle would have to be the same because in any triangle, all the angles add up to 180. So if I subtract these 2 from 180 or subtract those 2 from 180, I get the same number. Now that also leads into an idea that we're going to go over today. So they threw that one on there, third angle theorem. It came from semester 1, but we're going to use that idea some more. The second one, pretty much the same thing. Again, if you switch the orders around, as long as they were in the corresponding positions and stuff, it works. So check your answers there. 3 through 6, they were a little bit more, the answers had to be those values. Now, the way you set up your proportion to solve could have been different. Because really, anytime you set up a proportion to solve, there's 4 different ways you can write it in order to get a correct answer. For these, again, just make sure when you write that proportion, you write them each in a corresponding order. So for the first ratio, if you did big figure on top, small figure on bottom, make sure that the second one you follow the same order of big figure on top, little figure on bottom. If you did little figure on top, big figure on bottom, then little figure goes on top, big figure goes on bottom for the second one as well. You have to make sure both ratios follow the same order in order to have a correct proportion. All right. Out of those 4 down at the bottom for 3 through 6, are there any out of those 4 that you want me to specifically go over right now? Or do you just want me to pick one at random? Some of that work here yesterday, so. Any? Random. All right. Let's just do number 6. 6 is probably the hardest one, so that'd be a good one to do. Actually, I think 6 is probably the hardest one on this entire worksheet. So on number 6, they gave us a couple pieces. The thing that made number 6 challenging was they did not give us any other angles except for that right angle. Now they told us that they're similar figures, but how to know which ones to set up, that was the tricky part for number 6. We have these 2 sides, 8 and 10, right? Now, 8 and 10, they are 2 numbers, so we definitely know which one's bigger. Over here, we have 2 expressions. But based on how they're arranged, we should know which one's bigger. So, which number is bigger out of x minus 1 or x plus 2? X plus 2, right? If I added value instead of subtracting, it has to be the bigger number. So that means that x plus 2 down there at the bottom should go with which number over here? The 10. So x plus 2 and 10 had to be in corresponding positions. That means that the x minus 1, and I think that says 8, right? And 8 were in corresponding positions. So set up my proportion. It doesn't matter how you set up your first one. So let's say I did 10 over x plus 2. Well, I did the little triangle compared to the big triangle. So when I do the other side of this, I need to make sure I set up in that same order. So I'm going to do the 8 on top for the little triangle and the x minus 1 on bottom for the big triangle. Now we can cross multiply and solve. So when you cross multiply here, we have 10 times x minus 1, and we have 8 times x plus 2. We are going to have to distribute. So there's a little bit of work here on this problem, and I know there's not a whole lot of space, so I'm going to save a little bit of space by not showing the in-between step of like what I'm actually multiplying or dividing. But here I'm distributing, so 10 goes to x and negative 1, so that's 10x minus 10. 8 is being multiplied to both of those, so 8 times x is 8x. 8 times 2 is 16. Now, I need to get like terms the same side. So the 8x I can bring over this way by subtracting it. So 10x minus 8x leaves us with 2x. And this is what I'm saying. I'm not showing that in between step of actually subtracting the 8x. If I did move 8x over this way, I can go ahead and move the 10 the opposite way. So I have negative 10. So I'm going to add 10. And that gives me 26 on the other side. So the last step is going to be to divide by 2. And x is 13. Any questions so far? That is, wait. Pretty much, yeah. So anytime we have to solve, we're going to set up a proportion, cross multiply and solve, yes. Let me figure something out real quick. Hold on. All right. So now on the other side, all right, pretty much 1 and 2, just like 1 and 2 over here. 3 and 4, just like 3 through 6 over here. The two that are different on this side are 5 and 6. Now 6 isn't too bad. It's actually fairly easy. You just have to make sure that you're matching up the correct sides with the shorter side and the shorter side and the long side and the long side. So they are proportional and the scale factor is 6 to 5. But 5 is a little bit different. So let's look at 5 next. 5 is the one that's talking about scale factor and perimeter. Now, they give us all these values. And I know that's kind of blurry on here since I took a picture from the answer key. So let me add these numbers back on. We had 15 here between A and B. CD was 20 and ED was 10. And then over here on the other figure, PP was 21. Now, you also had congruency marks on these figures. So we actually knew more parts. So we could have said these other two pieces that weren't labeled on the first figure were actually also 10. Now, as far as the scale factor goes, well, on this figure, we got 21. So I'm gonna have to match that up with whatever piece matches over here, which would be the 15. Again, it's turned, it's flipped around a little bit. So we're matching up 15 and 21. So 15 and 21, both divisible by 3. So when we divide by 3, we get 5 over 7. And that's how we got our scale factor. That's our first answer. Then we need our perimeters. Well, since we know every single one of the sides here, all we're doing is adding these up. 10, 10, and 10 is 30, plus 20 is 50, plus 15 is 65. So our perimeter on the first figure is 65. On the second figure, we only have one side, but we have scale factor. The scale factor works for any single dimensional measurement, including the perimeter. So we're going to set up a proportion, just like we would on any other problem. 65 is from the small figure. I'll get that in just a second. 20, oops, not 21. X on the bottom. I know. I'm gonna grab it a second. Put X on the bottom. We're going to cross multiply and solve. Not here. Not there. Yeah. All right. Where was I? So we have our proportion set up. We have our scale factor. We have our perimeter from the first one. Put it over X for the perimeter of the second one. Now it's time to cross multiply. Now, these numbers are somewhat big. So we have 5x is equal to 7 times. Oh, I'm getting ahead of myself by going that grab some bar. Hold on. I'm already thinking next step. All right. So we got 7 times 65. Now, 7 times 65, that might be kind of challenging to multiply because that's now going to be a bigger number. You could use a calculator. And again, it'd be easy to do this with the calculator. You multiply that, and then you bring 5 over, divide it, and you get your answer. However, keep in mind, some of these questions, even ones that sometimes have bigger numbers, could potentially still be on, you have to say at the end of the year without a calculator. So something like this is actually still somewhat easier to do without a calculator if you think about how you can simplify those values first. So on here, again, like I said, you could use a calculator to finish that off, but if I'm not using a calculator, I still gotta get that x by itself, so I'm gonna go ahead and move that 5 over right now before I even multiply that part out. And the reason why I'm doing that is because if I move that 5 over, I can go ahead and simplify. On this side, I'm gonna 5 cancel out. On the other side, 65 and 5 have common factors. Divide them off and get smaller values. So divide by 5, 1 on bottom, on top, 65 divided by 5 gives me 13. So now, for my final answer, all I have to do is multiply 7 times 13, which is a little bit more doable in your head or by hand. So 7 times 13 is going to give us 9. All right. Any other questions on this page? So that was homework. Now, we're going to move on to assignments. I passed these out, right? Okay. So on the worksheet, all right, first thing I want to look at is just the top part of this. So on here, we have 3 similarity statements, all right? But yeah, similarity criteria. So in the last semester, we talked about congruent triangles. We talked about shortcuts on how to tell whether or not triangles were congruent, and we had 5 different ones, which I have listed over on the board there. A, S, SAS, SSS, HF, right? Those are to tell whether or not triangles were congruent. There's a much shorter list to tell whether or not triangles are similar, mainly because the first one is AA. We only need 2 angles, because if we know 2 angles in a triangle are congruent, then we automatically know the third angle has to be congruent. So we have all 3 angles, and if we know all 3 angles are congruent, the triangles are going to have to be similar. So AA similarity, if you have at least 2 angles congruent, then the triangles are going to be similar. For side similarity, if all 3 sides are proportional, so have the same ratio, then the triangles are going to be similar. And the last one, if you have 2 sides that are proportional and the angle between them is the same, so the angle between them is congruent, then the triangle will be proportional. So those are 3 shortcuts for similarity that we're going to talk about. And then give us a couple of examples here. The first one, this is using all 3 sides. They have the sides, and down here, they match them up. How do they actually match them up? Well, they went in order from smallest to biggest. So here, the 6 and the 9, those are the 2 smallest sides, they use those together. Then the medium size, we have 8 and 12. And the biggest side, 10 and 15. So they match them up in order from smallest all the way down to biggest, and they did it in the same order. All reduced to the same number, so they are proportional, which means that the figures are similar. Same thing over here. They matched up sides, and they had an angle between them that was congruent, so they're able to say that these 2 triangles are similar. On the other side of the top part of that paper, so on the other half, I should say, there is a couple more examples. Again, the first example is almost exactly what we were doing yesterday, but here they have 2 parts for you to solve, not just 1. Now, it's still the same idea, and notice there's 1 side that you know for both figures. Well, they use that same ratio for both proportions. They just switched out the other ratio, and then they solve by cross multiplying and solving. Same steps, same thing. On example 2, this one, they don't really give you enough information to know that these 2 triangles are similar at first glance. But they talk about this in terms of we have these 2 figures, we have their shadows. So there are 2 angles that we know have to be congruent. This angle at the ground going up to where the sun would be, called the angle of elevation, is the same in both figures. And we have a right angle from the ground to the height of the person and the flagpole. If you have 2 angles that are the same, then the triangles have to be similar. So we could use proportions to solve on a problem like that. So that is one that you're pretty much gonna guarantee see on a test or quiz or FSA. We almost always have problems with, two different figures and their shadows, and you're gonna have to find the missing piece. Alright, the back is where I wanna focus more time with today. And this worksheet, I'm not giving you the whole thing for homework today. Now, between today and tomorrow, all the problems on there are gonna be assigned. But for today, we're focused on this side. I'm gonna focus on the first two parts, AA and SSS. So, up there for AA, you have several figures. You need to get one? Oh, you came in. Okay. Anybody else came in late? I missed? No? All right. So, for angle similarity, we have 6 different shapes here. We're only going to look at numbers 1 and 3 for right now together. Do we have enough information to say the figures are similar based on AA similarity? Well, in order to say that we have enough, we would need to know that we have 2 angles in each figure that are congruent. Look at number 1. On number 1, is there 2 angles that are labeled as congruent? No, right? There's not 2 angles labeled as congruent. Does that mean that AA doesn't work? No. That means first we need to see if there's anything that we can identify as being congruent. Just like we did when we were doing our congruency criteria. You were given the triangles, and a lot of times you have to use other properties first to say, all right, I know these are congruent, I know these are congruent. Do I now have enough pieces? Same thing here. Look at those 2 triangles. Are there any parts in there that I know for sure are congruent? Yeah. Vertical angles, all right, that'd be one set that we could definitely label. So here at the middle, the 2 angles coming off of point E are vertical angles, and vertical angles have to be congruent. So I do have one set of angles that are now congruent in the 2 triangles. Are there any others that I know for sure have to be congruent? How about this? What other piece of information did they give us in the figure? Because they did label something. What did they label? All right, yeah. That little arrowhead there, that's telling us that those 2 lines are parallel. Now, when we have parallel lines, we should know some parts are congruent. So think back to when we had parallel lines cut by a transversal. There's different parts in there that we should automatically know are congruent. What angles in there do you think would have to be congruent since we're dealing with parallel lines? Any guesses? When am I having marked up? What other angles do you think might be congruent? Take a guess. Well, all right, I already have angles marked on E. All right, let's start with C. Which angle do you think is congruent to C, just based on looks? G. All right, so C and G. Now, why would C and G be congruent? Again, going back to the idea of parallel lines, this angle and this angle are congruent on parallel lines. Why? Those are what we call, what does that stand for? Alternate interior angles. You have 2 angles that are inside 2 parallel lines, but are on alternate sides of this transversal. They have to be congruent. Now, the same thing is also true for D and F. So we could actually mark all 3 angles. We have enough information there to say all 3 angles. So again, do we have at least 2 angles marked? Yes. So can we say that these are similar by AA similarity? Yes. So these are definitely similar. And then you'd have to write a similarity statement. Now, to make our similarity statement easy to write, once you have it labeled, use the marks that you did in order to help you label it. So I'm going to go in order: 1 mark, 2 marks, 3 marks. So I have E, C, D. We're going to do E, C, D is similar to, again, 1, 2, 3, E, G, F. E, D, F. Again, could you write in different orders? Yeah, there's different ways you can write that, but that is one that would work. All right, go down to number 3. I don't have parallel lines to help. In fact, these two triangles aren't even touching. Do I know any of the angles are congruent in number 3?
Yeah.
Yeah, which ones? All right, Y and C. Because on both of those, they tell me that Y and C are both right angles. So I at least have that piece that's congruent in both. Now, are the other two angles that they gave me congruent? No. So do I have enough information here? Not yet. Can I solve for anything else? Yeah, what do I know about triangles? All the angles have to add up to 180. So take the two values that we have, the 90 and the 39, add them up, subtract them from 180. Guess what you get? 51. The other way that you could look at this, so all the angles do add up to 180. Also, when we had right triangles, the two acute angles had to add up to what? Two acute angles had to add up to 90. So I could do the same thing over here, but just subtract 51 from 90, and guess what I get here? 39. So do I have enough information? Yeah. Again, it's not about what they have labeled currently. It's what do you know? What can you figure out? Do I have enough information given to find out if I had two angles that are congruent? So in both of these cases, yes, I did. The triangle, I'm just going to go smallest angle to biggest angle. ESY is similar to triangle HWC. Again, are there different ways I could write that? Sure. So that would be one order that works. All right, I want to do one of the examples from the other set on this page, which was side, side, side. So for side, 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 now this one carries over on your paper, so part is at the bottom, part is at the top. Again, we need to look at the values and say, right, are they going to be congruent? Well, on here, sorry, not congruent. When we're doing the sides, they have to be proportional. So on here, we know that we have all three sides listed. I need to look to see if they are proportional, meaning I need to be able to write ratios that are equal. So I need three fractions here. What are those three fractions going to look like? So how do I combine these and match them up to write the correct ratio? In one set of sides, the two things would go together. What was that? All right, KN, which was 9, and DE, which is 14. I would say that those definitely go together. Wow. We're just talking about length. What's true about those two lengths in each of those triangles? Something that's similar. They're in each triangle respectively, they're the smallest or shortest side, right? So on here, those would be the two that would have to go together. Then we match up the medium size lengths. Then we match up the biggest lengths. So we have 9, 14. The next biggest was 13.5 and 21. Then we had 20.25 and 31.5. For all three of these, how do we actually know if they are equal? Because we have decimals in there. These look pretty hard to tell whether or not they're actually going to be the same. How do we know? What are you going to do with it? Currently, I have written as fractions, right? You have a calculator? Somebody who has a phone app, which is way too many people. Change it over to your calculator for a second. Help us out. Do 9 divided by 14. Tell me what you get. 64288. All right, I'm just gonna stop it there. All right. But it's a long decimal, right? And if you kept going, there's more decimals. I think the next one I saw when there was 5. But that's what we got. So then do the next one. Is the same number? All right, what about the last one? You can't just stop at the second one. You gotta check all of them. Same exact thing. So each and every time we get this same ratio, all of these are equal to that same number, right? So since they're all equal, they are proportional, which means that these two figures would have to be similar. No. Okay, I don't have a spot for this one yet. This one is not showing.
I did it right. I think
This is not, yeah, that one. Yeah, the one I'm currently doing is not spot for it. I'll have a spot for it later. I haven't had a chance to upload it. All right. So all these are the same. So then you can write a similarity statement. Again, similarity statement might be a little bit challenging on this one because the angles aren't labeled. But an example of a correct statement here could be R and K, and then S E B. All right, I'm going to stop there. What I want you to do for today on this paper is just 1 through 12 on this side. All right. So on the side that has AA and SSS. I don't want you doing the other side yet, because I think that side's a little more challenging, and I want to say that for tomorrow. So just 1 through 12 on this side. All right. And that's where we're stopping for today.